The first article I viewed was possible effects of a free healthy school meal on overall meal frequency among 10 to 12-year-olds, the School Meal Project. In this study, they're trying to figure out if a free meal every day for a year can help how often the kids will eat. They record parents' social economic status to see the correlation between frequency of meals and income. They compare the control group, who doesn't receive any meals, and the intervention group, which I'll be saying as the experimental group that does receive the free meals. The population includes middle schoolers in Norway. The population of the two schools is 219 kids. The sample size is 10 to 12-year-olds that attend the school, so there's a total of 164 children at baseline, and one parent of each child is invited to participate. Many tests using the stats class was incorporated into this study. For all the tests, the p-value of less than 0.05 was considered significant. Differences in age at baseline were analyzed using independent samples t-test. Then the differences in proportions of children eating different meals were analyzed by using chi-squared tests. Logistic regression analysis were conducted to calculate odds ratios with 95% confidence intervals of overall intervention effect on eating breakfast, lunch, and dinner, and also viewing the regular meal frequency on weekdays and during weekends separately. The mean age in both groups were 11.1 years old. They had 38% and 53% girls in the experimental and control group respectively. 53% in the intervention group had high social economic status, while 63% had high social economic status in the control group. There were no difference between these two groups except from eating supper every weekday. The difference was in favor of the intervention group, which was a p-value of 0.036. At the second follow-up, the control group had more frequent breakfast consumption in the weekends compared to the experimental group. The p-value was 0.017. Both these values show that they are not statistically significant. The study indicates a free school meal for a year doesn't improve the overall meal frequency. The results actually suggest the intervention group skips breakfast during the weekend to a larger degree than the control group. They found that the children receiving the free school meal were less likely to eat breakfast during the weekend compared than children in the control group. The sampling technique they used was stratified. They chose two schools that are similar in the county, type of location and school size, and chose students aged 10 to 12. This can be biased because there could be a non-response bias because throughout the study people stopped following up or participating in the study. There was 219 possible students who were eligible to participate, but 50 plus didn't participate because of parental consent or refused to participate. This study included many variables in this experiment. Age was one of them, which was quantitative and discrete. So the age would be the children that are participating in the study. Social economic status of parents, that's qualitative, and this is to figure out how much money the parents are making that can relate to meal frequency. The county is qualitative, so that's just making sure that both the two schools are in the same county so they can get accurate results based on other factors. Sex was one of them, so that's qualitative and discrete. They separated the males from females and made sure to take note of that. Parents' level of education, qualitative, because maybe based on the education that they get, how likely they are to know about these things and if they went to college or not. So it's similar to social economic status. And then frequency of eating meals, that's one of the most important parts, are quantitative and continuous, because it's the main part of the study to figure out how frequent students are eating on during the week and on the weekends, and to figure out if a free meal for a year contributes to helping students eat more often. The next article I viewed was Strategies and Limitations in App Usage and Human Mobility. There was a study of 400,000 people based on phone usage and the amount of stops when traveling to a destination in correlation with apps that are used. They also wanted to find the correlation between app usage and age. From the 400,000 users, they stopped at 138 million locations, used 69,000 applications, and were opened around 1 billion times. During the 6 months of study, people used on average 27 different apps, which consisted of mostly social apps such as Instagram, Facebook, etc. They find a significant and positive correlation, the R value 0.17, p value less than 0.001, between mobility and app capacity, but also between the individual number of new locations and new apps, which the R value is 0.11. These positive and significant correlations might be the trade-off between mobile phone usage and mobility, where people tend to decrease their mobility when they use their long for longer times, and vice versa. They were able to obtain this data by looking at the raw data. They were able to obtain two different data streams of the same users to support their analysis. The user locations data stream, composed of user ID, date, time, latitude, longitude, and the user application usage data stream, composed of user ID, date, application name, aggregated time spent, and number of times opened. The researchers also viewed two groups: the keepers, who are people who are more loyal to their apps, and explorers, which are people who discard an app, add apps more frequently. So the mobility explorers embrace a new location every 17 weeks. Keepers tend to retain a location for 61% of their time, while new locations are persistent for explorers who maintain them for 40% of the observation window. The two distributions are well separated. This result shows that people's behavior in the digital world is more repetitive than the physical one. The researchers then analyze the relationship between the age of the users in their dataset and their app and mobility capacities. They find a strong negative correlation between age and app usage, which is shown in this figure. It shows that younger people, those aged between 18 and 24, have the highest average number of applications in their app space. So it just shows as mobility decreases, app usage decreases, age is increasing. The sampling used was stratified sampling, and I say this because they're identifying two profiles of individuals, which are app keepers and explorers. The keepers are the ones who keep the apps, are more apt to keep the apps, and the explorers are more likely to discard and add more apps. And this is regarding their use of mobiling applications. And then a potential bias would be the non-response bias, because in order for people to participate, they have to accept allowing the researchers to record all of the data and usage of their phones. Despite it being completely anonymous, people may still choose not to participate. So there's that, and then also a non-representative sample because they're only targeting Android users and not other users. Like iPhone would be a big one that they could test on. Some of the variables studied were user location, which was qualitative and discrete, app usage, which is quantitative and continuous, and age at percentage. It says qualitative, but it's supposed to be quantitative and continuous. And then the keepers are quantitative and discrete, and the explorers are quantitative and discrete also.